So today let's talk about positive and zero exponent rules. So the first thing we want to start talking about is the basics of exponents, and that is, as I'm looking at this a to the x power, a couple things we need to know. One is the number or variable on the bottom. Okay, that is often called the base. And then the number up above right there, as you probably already know, okay, that's usually called, it's called the exponent. Or sometimes it's called the power. Now, let's talk about some of the basic rules. Basic rules of exponents, there's numerous of them. There's, depending upon how much you want to break them down. But we're going to talk about 4 of them today. The first rule says, if I have the same base, okay, and I'm multiplying right here, what you do is you add your exponents. So a to the x times a to the y actually equals a to the x plus y. Okay, next rule says, if I have 2 variables or numbers being multiplied together, and I have an exponent on the outside like that, what I do is I distribute it. So this would become ab in parentheses to the x would become a to the x, b to the x. Now something to remember right there is that this has to be multiply in here. Okay, it can't be add, can't be subtract. Okay. Next rule. Next rule says if I have a to the x to the y, so it's like a power to a power, what you do is you multiply those exponents. So this becomes a to the x y. And last but not least, this one says anything to the 0 power is always equal to 1. And there you go. There's 4 basic rules of exponents. Now there's others, and we're going to talk about those. But right now, let me go back here real quick. Let's just say xy right there. So let's go back or go down here and actually talk about simplifying some of these. Okay, and let's actually apply some of these. Alright, now this first one doesn't really use any of those 4 rules of exponents, but just talks about how do you figure out what 3 to the 4th is. Now remember, an exponent is just like a multiplication shortcut. 3 to the 4th simply means 3 times 3 times 3 times 3. Okay, so it's 4 of those 3's. And then if you multiply all those together, you end up getting 81. Ooh, that's rough looking right there. 81. There you go. Okay, next one. Negative 2 to the 2nd power. Now, something that sometimes you don't think about is, it says negative 2 here, but really kind of what this means is negative 1 times 2 to the 2nd power. So when I do this, what I'm really doing here, this second to the 2nd power, is I'm just doing 2 to the 2nd power. So this becomes negative 1 times 4, or negative 4. Okay. Now that's only true if you notice here that this one is written like this, while this one over here is written like this, where it has a negative 2 inside the parentheses. So if that's true, what that means is negative 2 times negative 2, which is 4. Okay, so there's a big difference between this one and this one. Remember, if it's in parentheses, you include the negatives. If it's not in parentheses, then you don't include it, okay, and it ends up being a negative. Okay, so let's move on down. Let's actually apply some of these rules of exponents that we talked about a few minutes ago. Okay, so number 4 here says x to the 2nd times x to the 5th. Well, my bases are the same, so that means I can use that first rule of exponents and I can add. So this just simply means x to the 2 plus 5, or x to the 7th, just like that. Easy enough. Next one, it says x to the 3rd to the 4th, so it's a power to a power. So you're going to multiply your exponents, end up with x to the 12th. Okay, number 6. Number 6, now this one is similar, this one is similar to rule number 2 up here. Okay, except for this time it's division. Now, it doesn't really matter that it's division. You still are going to follow that same rule, and that says if you have an exponent outside of parentheses, like this, and it's not add or subtract, so if it's multiply or divide, you're going to distribute. So I'm going to distribute this to here and to here. So it becomes r to the 7th, and then it becomes g to the 3rd to the 7th. And according to that last rule, you end up getting g to the 21st. Alright, let's look at the next over here. Alright, so a lot of stuff going on this one. So again, you have this variable on the outside right here, so I'm going to distribute this. Now, you have to distribute it to everything, the 5, the x to the 4th, and the y to the 9th. So what you have to remember is that this 5 has an exponent. Even though it's not written, it has one, and that exponent is a 1. So it's going to be to this, so 2 times 1, so it's 5 squared here. X to the 4th times 2, so that'd be x to the 8th, and then to here, y to the 18th. So if I simplify this, you end up getting 25 x to the 8th, y to the 18th. Okay, easy enough, I think. Now, let's do the last one here. X to the 0. Well, that's an easy one. Anything to the 0 power is 1. Just like that. And there you go. There's some basic rules or basic applications of 4 rules of exponents.